Before we had even access to AMI data, we really didn't have insight to behind-the-meter consumption and what that was like. So once we adopted AMI, we could see what customers were doing behind the meter, but we really didn't know how they were using that electricity. So Bidgely's Analytics Workbench platform gives us a little bit more insight into that. One of the points would be that we can design better electricity rates, so time-varying pricing. That's a hot topic, but to design the rate most effectively that works for customers, and customers who are electrifying, that's something we can get insight on if we understand who is electrifying and how they're doing that. Another way would be when we're trying to understand how our ecosystem is changing, especially with, we have renewable energy targets of 80% by 2030. We're probably at about 40% right now, roughly. And we have to understand how that change is happening from a bottom-up approach rather than just a top-down approach. So it enables us to do that as well and kind of load forecast in a more accurate way. At the beginning of the journey, you really don't know what to expect. You're given these numbers and classifications, and we're trying to validate whether or not that even makes sense to us. We don't want to use things blindly, of course, especially if we're going to drive insights from that. So the first thing we looked at was electric vehicles. So we started validating with data sets that we knew, customers we knew had electric vehicles. We wanted to compare the consumption and the classification of the Analytics Workbench to those customers that we just knew had electric vehicles, to understand how close on the mark is this algorithm. Because we know there's more than just those customers in the pilot. There's no machine learning algorithm that perfectly classifies every customer. But once you understand kind of the foundation of that, you can then use it. So at the beginning, it was about 50% of customers that were in that pilot program were being picked up, which isn't bad. It actually increased to about 65% later on. But then when we started comparing to customers who answered in a survey they did not have an EV, the false positive rate was really low, which is really good. So it actually worked out really well that we could use those two metrics, then scale what we're seeing in AWB to get a rough approach of what is actually happening on our grid. So time-varying pricing is something we spend a lot of time studying right now. It's something new in Nova Scotia. We're in our 4th year of what we would call our pilot program for TVP. And in that pilot program, we classify customers into electric and non-electric heat. Because we want to understand how do these rates affect customers who use electric heat and those who don't. And when we took our model and compared it to what Bidgely was telling us, because Bidgely also has the Analytics Workbench platform, we compared the two, and what I looked at was, well, we agreed about 82% of the time, which is great. It doesn't mean the other 18% means that one of us is wrong. It's just the method either detects more easily than the other method. And when we looked at those differences, we found that Analytics Workbench was classifying customers as electric or partially electric, and we were saying they were non-electric. We found that a lot of times we might want to switch our tune in our model. So we actually refined our model. It wasn't all the time, but when we anecdotally flipped through hundreds of these customers' consumption profiles and comparing it to temperature, we thought, let's refine our model a little bit. So it added a few more percent to that 82. So we might agree about 85% of the time now. But what it did was we refined our methods. So that was really good. And the Analytics Workbench approach is very different than what we've done traditionally. So it validates what we would have expected, which is good. It might also give us insight into something we never even would have thought of.